36 degrees, 42 minutes, and 30 seconds to radians. You will have to change 36 degrees, 42 minutes, and 30 seconds to a decimal portion of a degree. Continuing then, 30 divided by 60, this is equal to 36 degrees, 42 decimal 5 minutes. And this in turn is equal to, by dividing 42.5 minutes by 60, is equal to 0.7083, 3 repeated, and so it is approximately equal to 36.708.3. Since 180 degrees is equal to pi radians, and 1 degree is equal to pi divided by 180 degrees, then 36.7083 degrees will equal 36.7083 multiplied by 3.14159 over 180. Using your calculator to work out the amount, the result is approximately equal to 0.64068, and that's of course in radians, written or understood. In another example, convert negative 2.45 radians to degrees. Since 180 degrees is equal to pi radians, of course pi radians is equal to 180 degrees. And 1 radian is equal to 180 degrees divided by pi. So if 1 radian is equal to that many degrees, then negative 2.45 radians will be negative 2.45 times that amount. So the conclusion is negative 2.45 radians is equal to negative 2.45 multiplied by 180 divided by 3.14159. And the result is negative 140.374659 degrees. We'll do one more example. Convert 3 pi radians to degrees. Since pi radians is equal to 180 degrees, then 3 pi radians is 3 times 180 degrees, and that's equal to 24, 54, 540 degrees. The next thing we have to deal with are the trigonometric functions of any angle. Trig for short. I must begin by drawing an angle in standard position on a graph. First, the initial arm emanating from the origin and along the positive x-axis. There is an angle in standard position on the graph. On the terminal line, select a point and refer to it as x, y. The length of this terminal arm from the origin to this point can be determined. You can observe that if I drop a perpendicular line to the x-axis from that point, that I have a right-angled triangle with the right angle here. It follows then that the length r, which I will indicate by using r for that length, r is equal to the square root of x squared plus y squared. This length will always be a positive number. POS for positive and NO for number. Note that x and y can be positive or it can be negative. If the terminal arm happened to be in this quadrant rather than where I have drawn it, then x would have been a negative number and y positive. If I continue the rotation and the terminal arm occurred in the third quadrant, then both x and y would be negative, and finally in the fourth quadrant, y would be negative and x would be positive. So x and y can be positive or negative depending on which quadrant the terminal arm is located. The trig functions are defined as follows, and you should memorize them. Using x, y, and r in the definitions are the following. On the left, I will list what I refer to as the primary ratios, and the other as the reciprocal ratios. The sine of the angle, or the rotation angle, which I will refer to as theta, written in full, sine theta is equal to y over r. The short form for sine, which we always use, is sin. Sine theta is y over r. The reciprocal ratio of sine is secant. R over y. The reciprocal ratio of y over r is r over y, and we call that the secant. The short form for secant, which we always use, is simply sec theta. The next primary ratio is the cosine. Cosine theta is equal to x over r. The short form for cosine is cos theta, and that's the one we always use. Cos theta is equal to x over r. The reciprocal ratio of cosine, which would of course be r over x, is called the cosecant. R over x. There are two short forms for cosecant, and they are cosec for cosec, or simply this spelling, CSC for cosec. The third primary ratio is the tangent of theta. and it is equal to y divided by x. In short, tan theta is what we normally use. The reciprocal of tangent theta, of course, would be x over y, and x over y is defined as the cotangent. Or simply cot theta in short. As I explained, you must memorize the primary and reciprocal ratios. Most trig functions are irrational numbers. Trig functions are therefore often referred to as transcendental functions. If a unit circle is drawn using the origin as the center, then the sign is the projection of the terminal arm length to the vertical axis, that is, the y-axis. Let's assume that this as close as I can get it, is a unit circle. Then this is the coordinate 1, 0. This is the coordinate 0, 1, and so on around the entire circumference. Given any particular point on the circumference, this one for example, since this is a unit circle, the sine of the angle theta is equal to the vertical line here, which is y, divided by r, and since r is equal to 1, this is equal to y. This indicates that if you take the projection, which is a vertical projection of the terminal arm from the point to the origin to the y-axis, that's the length that you would get. This distance here is the sine of theta. Similarly, the cosine is the projection of the terminal arm to the horizontal axis, that is, the x-axis. The cos of theta is equal to x over r, but since this is a unit circle, r is 1, that is therefore equal to x. This projection then is this distance. So this distance here is equal to the cos of theta. The tangent is the vertical length on the tangent line drawn through 1, 0. If I draw a tangent line through 1, 0, like that you can see is a tangent to the circle at the point 1, 0. From this point of intersection with the x-axis to the intersection of the terminal arm with that tangent, which is approximately up there somewhere, then this is the length from there to here, which is equal to the tangent of theta. The tangent of theta is equal to y over x. Similar triangles, draw another angle in standard position, and let's assume that the terminal arm passes through the coordinates 3, 4. 3 this way and 4 this way. We'll call the angle again theta. Then the sine of theta, which equals to y over r, is simply a matter of placing the coordinate of y in that position and the length r, which is the length of the terminal arm from the origin to the point. And r is found by taking the square root of x squared plus y squared. In this case, it is 4 squared plus 3 squared, which is 25, and that amounts to 5. Consequently, sine theta is equal to 4 over 5, or 0.8. The reciprocal of the sine of theta is the cosecant of theta, and that's equal to 5 over 4. Similarly, the cosine of theta is equal to x over r, and this is equal to x, which is 3, over r, which is 5. The reciprocal, which is secant theta, is equal to 5 over 3. And finally, the tangent of theta. The tangent of theta is equal to y over x, and that'll be 4 over 3. The reciprocal of tangent of theta is the cotangent theta, and that's equal to 3 over 4. Drawing in the right angle triangle from the point 3, 4, by drawing a vertical line, I will introduce some ratios which are useful in dealing with plane triangles that will be covered more thoroughly later on in this lecture. Here you can see the right angle triangle with this angle at the origin equal to theta. This is the hypotenuse opposite the right angle, and we will therefore indicate that by using the letter h. The length of the side opposite theta will be indicated by the letter O for opposite. And the line here, the length of this line, is often referred to as the adjacent side to the angle. Of course, the hypotenuse is also adjacent to the angle, but it already has a name. So we'll refer to this side as the adjacent side and refer to it with the letter A. I've already shown you what these primary trig functions for theta equaled using the point whose coordinates are 3, 4. But now I will use another method of determining these primary ratios using the letters O, H, and A. I've just shown you that the sine of theta is equal to y over r, or 4 over 5. R, recall, was equal to 5. The length from the origin to the point 3, 4. As you can see, 4 is the length of the side opposite the angle theta. And so we can define the sine of theta in that right angle triangle as equaling the opposite over r, which in this case is the hypotenuse, which therefore is represented by h. In a right angle triangle, you should memorize this definition. Similarly, as I have just done, cos theta is equal to x over r. And in this case, of course, 3 over 5 was the result. Now it's useful to note that in this method of defining the primary ratios, that the cos of theta is the adjacent length of the right angle triangle over the hypotenuse. So we write A over H. And finally, the tangent of theta is equal to y over x, which is 4 over 3. That is represented by the letter O for opposite and A for adjacent. And consequently, in a right-angled triangle now, the tangent of theta, which is 4 over 3, the result I did in the example just before, and finally then letters which represent sides, the tan of theta is defined as the opposite length over the adjacent length to the angle theta. So these are the definitions for sine, cosine, and theta that you should memorize. Of course, the reciprocal ratios, cosecant is simply the reciprocal of that ratio. For the reciprocal ratio, the secant, we simply have the reciprocal of that. And for the cotangent of theta, we simply have the reciprocal of that one. Now, if I place 2 points on the graph, say here, call it x1 comma y1, and another point here, call it x2 comma y2, all these points, x1 comma y1, x2 comma y2, and 3 comma 4, are different points and consequently will have different coordinates. If I complete the triangle, the right-angled triangle, using those points in them, here I have the one right-angled triangle with coordinates 3 and 4. Then I have another right-angled triangle here using x1 comma y1. And finally I have a third right-angled triangle going through x2 comma y2. These are all right angles. The trig functional value for a given angle is independent of the size of the right-angled triangle. We have triangles of different size here, but dealing with the same angle at the origin, no matter whether we have the point represented by the coordinates 3 comma 4 or some other point on that terminal arm represented by x1 y1, or another point on that same terminal arm x2 comma y2, the values of sine theta will be 0.8, the value of cos theta will be 0.6, and the value of tan theta will be 1.3 repeated for any one of those coordinates chosen. The next topic I want to discuss is related acute angles.